Hey there, welcome back to another video. I'm your tutor Roland, and we'll be discussing a couple more problems dealing with transversal lines and parallel lines in Euclidean geometry. So in this example, we want to find all of the unknown angles. In the previous video, we learned about three different major rules, and the rules form FUN. If you're interested in looking at those sort of rules again, go visit the previous video. So we need to define whether the line EF is parallel to the line CG, and then we need to explain why. So let's start this off by drawing the first transversal line, or the parallel line. Let's see what happens next. Okay, so we've got a set of lines that's been drawn. Let's see what we label as EF and CG. So we've got one line so far that's AB. We then have CD. We have EF and then CG. So we're looking to show EF being parallel to CG. We have a 90-degree angle over there. We have an obtuse angle at E of 160 degrees. We have a 60-degree angle at B. And so far, this looks good. All right. You need to make sure to go and check this previous video to this if you're unsure what's going on, because there are a set of rules that you need to follow to make sure that you understand this problem. We now will fill in other angles that we have that are unknown. We have Y, R, P, S, and X. We need to look at corresponding angles, co-interior angles, and alternate angles. Okay, so let's move forward from here. What do you think our first step will be? Let's write step 1. It's good to work in steps, especially when you're working in geometry, because it's very much a rule-based setup in terms of mathematics. So stick with the steps and your life will be a lot easier than if you don't stick with steps. So let's use the properties of parallel lines, and we'll use these properties to solve whether these lines are parallel or not. So we're looking at the line EF and CG. We've got 160 degrees at E, and we need to solve all of our angles. So I've copied the diagram down below. We see that we've got X equal to 60, and then Y and P being equal, as they are opposite angles. We see 160 should be equal to R, and we now need to prove. Okay, with that said, let's move on to step 2. Let's prove these guys. So let's determine the unknown values. So here we have angles on straight line at E. So the other angle for opposite the line EF would be 160 plus 20 makes 180. So therefore that angle would be 20 degrees. We see from the diagram that AB and CD are actually parallel. So this was actually part of the question. This will help life quite a bit. So if we know that those two lines are parallel, we actually can now start solving for the unknown angles. So we know that AB is parallel to CD. That's actually been given. That was left out of the question, and to be perfectly frank, a lot of people forget this when they're doing their questions. It's so important that you actually look at the question correctly, because something like that, which may seem like a little mistake, will totally block you from seeing the answer going forward. So with that said, let's not waste any more time. Let's say when the angle X is equal to 60, we know that's an angle because there's a hat above the X. We said alternate angles is the reason. So we say alternate angles because of the Z shape that is formed. We say that B is equal to 60, and therefore X is equal to 60, as the line AB is parallel to the line CD. We now say that the angle Y plus 160 is equal to 180 degrees, as I mentioned earlier. Therefore, Y would have to be equal to 20 degrees, and we call this the co-interior rule. So co-interior angles, because AB is parallel to the line CD. This is the structure in which you should write your answers. So AB parallel to CD, the straight lines, the straight angle would be 160. And if you look at co-interiors, you would say y is equal to 20 degrees, purely because of co-interior angles, which is formed by the U. If you look at the previous video, you'll understand what I mean. Alright, so moving forward from there, we will see that the value for y is 20 degrees as a result of co-interior angles. Right, 180 minus 160 is equal to 20, and there we have it. So let's move on. We will say that the angle P is equal to the angle of y. What is the reason for this? They are vertically opposite. Now, as you can see, these rules are very important. If you don't understand these rules, it's not a major issue. Just go back to the previous video and have a look at all those rules. If you understand those rules correctly, this section of mathematics is actually quite a breeze. Alright, and now we have it. P is equal to y, and therefore P is equal to 20 degrees. Right, let's go back to the diagram and have a look at that. We can see that P and y are both marked in purple. If y is 20, P is also 20. We then can look at the angle R and notice something. So the angle R is equal to 160 degrees. How did I get that? It's called corresponding angles. When we draw the F with a set of parallel lines, we'll see that AB and CD are parallel. So corresponding angles means that the shape formed by the F, as I've drawn here, shows that those two angles with the curly line shows 160 and R are actually equal. That is your corresponding angles rule. So therefore R is equal to 160 degrees. Okay, what do you think we're going to do next? Well, we've done most of the angles so far. So let's do the angle S and the angle X and 90 degrees. Where am I getting this from? Don't worry, I'll show you now. We say that the angle S plus the angle X plus 90 degrees equals 180, because angles on a straight line sum to 180, meaning they are supplementary. Once again, the word supplementary is understood in the previous video. So we see that at the point C, we've got 90 degrees, we've got X and we've got S, all of which add up to 180, meaning that X and S will also add up to 90, meaning they are complementary. Right, if you're not sure what the word complementary means, have a look at the previous video again. All of these terms are explained in that particular video. Right, so the angle S and the angle X are equal to 90 degrees if you add them together. So X is equal to 60 degrees, and then we transfer the 60 across to the 90, subtracting it naturally as you change signs across the equal sign, and we say S is equal to 30 degrees. Where did we get the X value from? Well, we can say that the X is equal to the 60 degrees at the top, as we can say from alternate angles, if I'm not mistaken, and therefore the remaining 30 degrees makes up the angle of S. Right, there we see S is equal to 30 degrees. Okay, now where do we move forward to? We now do our third step. As you can see, the steps are very important to solve questions like this. So in our third step, let's determine whether our two lines in question are parallel or not. So is EF parallel to CG? Right, if EF is parallel to CG, then P as an angle will be equal to corresponding angle S, but P is equal to 20 and S is equal to 30. Therefore, EF is not parallel to CG. And there we have it. Easy game.